I'm Anthony. I joined Vates recently, but I'm part of the XCP-NG team. And one other thing is I'm a maintainer of the tool part of the Xen repository.
Slide the window out of, there's a window over a window there, sorry.
So today I want to talk about the tool stack, especially libxl, and do a bit of history and try to propose something new. So yeah, the tool stack isn't so as part of the talk. I want to look at what you have today, and there are some shortcomings with libxl that isn't great for going on. And at the end of the talk, I'd like to present a bit of a design about new tool stack that could be useful for going to the future. So when libxl was created, or libxl, it was supposed to be used by to produce Citrix, Xen server, and Xen client. Xen client is now forked and outside of Citrix and called OpenXT. At the time, before libxl, there was a daemon called Xend, written in Python. And there was also other tool stack. Xen server have Xapi, still do. There were also a libvirt that were talking to Xend. And another tool that I did not really know called Xen VM, currently a part of the project called XCI that don't really exist anymore. One of the goals of libxl was to implement a common VM operation, so you don't have to. So not every project didn't, so they can be used by higher tool stack, higher level tool stack, and that's the one that we use to test Xen upstream, create VM, etc. So I did dig up a slide when libxl was introduced about 15 years ago. And some of the principles that were stated that one was supposed to be stateless. The idea is that when you do an operation on a VM, like create a VM or add a disk or etc., there is no demand or anything. You just start a new process, and libxl and the client XL could just integrate ask the system, look in a Xen store and ask a QEMU about the state of a domain. But that's not really true anymore. There is already a JSON blob store for each domain. Also, the API used by the library, presented by the library to be used by to be implemented in other tool stack. It's supposed to be simple. I don't know if it's really simple to use, but so yeah, another principle is about being implemented as a command operation only once and not have to do it again. And one last thing, the idea was to be simple to understand, but that's it's going back. Yeah, okay. but something the API was needed to be asynchronous to be able to be used by libvirt, and that made the code much more complicated. So yeah, that's the shortcoming of libxl. libxl does quite a lot of stuff to create a VM, like link fork exec to be able to start a QEMU. And doing that in a library that's not good. It means that you need to handle a signal like a sick child, and doing a sync child between a library and an application that Linux isn't really made for that. And we need a way to actually having a more cooperation between the application and the library. That make it awkward to integrate into other projects. Also, there was some issue at first whenever some file descriptor were opened. That's much better today in Linux with a glue exec can be often used at when the file descriptor is used. The problem is the file descriptor is that if the application also try to do a fork exec and start another program, the file descriptor files could be leaked. So some operation at libxl can take a long time, like creating a guest, and if to not sorry. That means that the application using a libxl could to be able to use libxl with libvirt, the API was made asynchronous, so libxl could do some operation and let libvirt continue do other things. And that means having a lot of callbacks. libvirt will call a function, and normally that will set up a callback, and the first function will return, and libvirt could do something else, and while libxl does this thing, this actually makes the libxl more complicated to understand, because libxl was actually written also with a lot of functions and a lot of callbacks, and if you want to figure out what is going on when you call one function, you have to figure out which function is next to be called in the callback by callback, and that makes it very hard to follow. And one other thing is that every time we upgrade Xen, you actually have to recompile your application against the new version of libxl. There is no stable ABI. And that's also a problem with Xen as well. The ABI between Xen and libxl is also not stable. So as a result, it's difficult to integrate with other program. One of the original objectives of having a Xen server and exactly use libxl have never been done completely. It's been attempted, but that didn't work or something like that. And the asynchronous API that make it writing code a bit more complicated in libxl is not even used by libert because it didn't work properly, I think. So we still have a serverless tool stack today. I still have exactly Xen PSD is actually doing something similar to libxl. And this is actually a new tool stack that a company called Edera started, and a project called Crater, all written in Rust. So yeah, that's not a. That mean. So what now? Do we still try to keep libxl going on and try to maintain it, or is it time to start thinking about starting from scratch and trying to define a better approach to create guests and manage them? And the same is the issue is that could help with a new design that when you create a Xen, when you create a guest in Xen, you don't really know the layout of the domain. So some time ago, I tried to port OVMF to a firmware that we run in a guest to PVH, a different way to start a guest, and I had to map a page in particular called chair page to get some information from them, and mapping a simple way would be to just do a malloc in VMF and just put the chair pages here, but that means having a bad that will destroy the page table as a guest. Something called P2M, and that will make the performance a bit worse. So so I try to put it this page far away in the higher away in the physical address space. That turned out to make a migration fail. So I had to try to find some other place and just below 4 gig. And if you knew what the memory layout of if you had a good idea of what the guess memory layout should be, it will be easier to figure out which address to use. So to replace libxl, I'd like to propose instead to have a demand a bit like Xen used to be. So, so having something that I actually have a better knowledge of all the domains and make it easier to manage them. And we need an API to communicate with the daemon. So the daemon will be responsible to create to Xen and create the guest, the domain and setting this up. But we need a way to describe this to describe this guest. So one of the ideas that have been proposed was actually to have an API where you can actually describe the guest fully and not have some tick like currently we have HVM versus PVH. With this API, we don't need to use these terms, and we would instead ask every device that you want to put in the guest, like HPET for timers, or which PCI device you want, like for the VGI card. Also, I describe what the memory layout is, rather than asking how much memory you want. And also describe what the status of the CPU register will be at the start. Because between HVM and PGH, there is I think the value of the register are a bit different. And since we could start from scratch, we could use one of the new modern language. I mean Rust. So yeah, just a bit more detail about the API. Something that we could actually create, but also list what you put in the guest on the domain and updating, etc. At least for the part of the domain creation. So I wasn't exactly sure, but I did read a bit of the code of how a domain is created and try to figure out what other devices that are created. And there are some devices that are emulated by Xen. There are some others that are emulated by QEMU, and they both take some of the address space for the emulation. They both emulate some part of the so usually a toolstack doesn't really exactly know what is going to happen to a guest creation. You just say, I want a guest on some emulation, and yeah, sorry, that's easy to understand. So with after reading all that, I try to see if how the previous idea of having describing the guest, which device you want and what memory you want, and start to write a few lines, like if you want the HPET timer, you need to ask for it specifically, and maybe put an address. But even if at the moment I don't think it's possible to put it at a different address, and that will create automatically. That will reserve an address specific for that if you ask for a list. Same if you want the VGA device, you will create it and ask to put it at a specific PCI slot. Today, libxl doesn't ask for anything and let QEMU put the the VGI PCI device at almost random location. You just allocated one by one on the next free slot. And that would reserve a few more space in the memory layout. And then instead of asking how much you want memory for the gate, we will ask that for the instead of asking how much RAM you want for the guest, we ask a specific address to be put as RAM for the guest. And then we need something at the start of the day for to execute. And at the moment, libxl does put a HVM loader and CBIOS and some structure to give a bit more information to a HVM loader. And you could put that as a part of the API and say we want to load this binary at this specific address. And that just there will be more code to do. And this isn't great to start from scratch for to have to rewrite libvirt and you might be able to create a compatible libraries that will look like libxl, but actually talk to this new daemon. And of course, we need a client as well. And that's about it for now. So,
so one partially compatible idea or proposal that I would like for everyone to consider, which is an idea that came from Bertrand, so to give credit where it's due and give to blame, is that we are now in Xen between the embedded and data center use cases. We are bifurcating the tool stack. This is what's happening in the sense that in embedded we are configuring using DOM zeroless. In the data center we are configuring using a tool stack. Now, if you only work in one of these two worlds, you might have not noticed, but it's getting worse. Like, let me give you an example. Targetable, untargetable, the property that I mentioned in my presentation is only enabled through DOM zeroless API. I say that you wanted to configure the same with Excel or any other tool stack, it will not work in the initial patch series. Now, let's say that by review, you asked the contributor JSON to do it. JSON will do it, but at a company, we have no interest in doing that, right? And it's never ideal to ask a contributor to do something that has no investment, neither personally nor the company in developing. And it will be the same the other way around. They say that I think EPAM contributed very cool patch series. That was the SCMI, wasn't it? And initially there was no support for DOM zeroless because whoever asked or EPAM wanted to do, there was no SCMI need for them to have SCMI support in DOM zeroless. But we have a need for that. We at AMD, at Xilinx, we care about the SCMI for DOM zeroless. So we made the request, and it's the same applies, right? It's not great for EPAM to have to do the enablement in DOM zeroless they don't care about, and the customer, their own customer has no request for it. So this is not great, and is the way I'm seeing it, it's getting worse. One idea that Bertrand had a couple of years ago is we already have an API to create domains, which is higher level, and that is the DOM zeroless API. And that works now on ARM x86, RISC-V is coming along, it's cross arches. What if we use that as an API also at runtime? Exposing the DOM zeroless API via an hypercall, much more aligned, right? Via an hypercall, so it will be a much higher level hypercall. So to make an example, think about rebooting a domain. Today, to reboot a domain, you need to make probably what, a dozen hypercall? You need to one to destroy, and maybe 6, 7 to create. Do you know how many?
No, I have no idea. But yeah, that's quite.
Right, so we are about
That's
talking about
quite
at
a few.
least 10, maybe something, because there is a
I-
domain
I-
allocation, the
so,
memory, the
I did
device.
what-
More than 10 hypercores, right? Yeah, so I realize the domain reset is a bit of a different implementation, but conceptually, that's one hypercore, right? You ask Xen, reboot me this thing, right? One hypercore. Now, if we create a better, higher level API in Xen, then first of all, we solve the problem, then, ask JSON to enable untargetable in Excel, right? But second, we also becomes much easier for anyone to use any language or whatever they want to implement the toolstack, because now the toolstack true is high level, right? Becomes a true high level software component that only deal with APIs such as REST or whatever.
Yeah,
The interesting
that's
part
the
from a
idea.
toolstack perspective, right? And then deals with the interesting part from a Xen perspective. Because the old reason why we're having this discussion is there are very minute details that are exposed in the toolstack. That to me is a problem. That's my 2 cents.
That's all very well and good. On the other hand, you say you want to kconfig out anything that you don't want to test. Are you suggesting we also kconfig all the way through the middle of this higher level hypercall?
I mean, the safety configuration. So I think we need to distinguish between what goes into production in safety. And like Mark used to tell me, the UART, for instance, you might take it out completely because that itself is something used for development or maybe not in production. So the production for configuration for safety is something that looks very different from a normal Xen system because it's going to be super narrowed down, right? But even a normal embedded configuration, an out-of-the-box, what a Raspberry Pi user will use, it will be 8.0 maybe, not even hard to domain control domain split. So there is no reason to kconfig out things for an out-of-the-box experience, right? It's the production that get kconfigured out. I don't know if it helps answering in any way the question. So for a data center Xen, I will imagine everything is enabled, or you would want to disable maybe the boot time on zero-less because you don't use it, maybe. But there is no strict. My specific need to kconfig out as much as possible is a production, not development or out of the box.
But just to be fair, when I made this proposal, the need at the time was to be able to pass the kind of device tree node that we create for a DOM zero-less domain. I was just saying, why on earth cannot I pass it through the device tree that I give to create a runtime domain? And just to create the equivalent, there was equivalent not possible to do at the time already, 4 years ago, 5 years ago. And then even if I had passed a device tree for my domain, I could not pass the information from DOM zero-less. And the question was, why not just generating exactly the same device tree, put it to Xen? Xen has the code to parse it anyway. Why do we need so much stuff added and hypercalls and etc. where we have already the parser for the device tree? Then you just need to generate a tool to generate you the device tree. That's it. That's an ARM-specific solution, which is now starting to pop up as a potential also x86 solution. But if you do that, then you just need a tool to generate your file. You can do that offline. You can do that whatever you name it. And then you have just an hypercall to pass this configuration binary blob and then parse it in the same way. Yes.
I mean, when I looked at this, it looks very much like device tree to me. So I was going to ask why not use device tree to pass that information, because the list that Anthony made, it looks like basically like device tree. So
that's exactly the point. We already have that functionality. We are going to have the functionality in Xen.
Yeah.
Right? Because we're going to have that functionality in Xen because we need to support it for DOM zero-less. The DOM zero-less API and hyperlaunch is now identical. So we have it on both arches, and RIS5 is coming along. So we are going to have it everywhere. We might as well use it.
One question that I have though is that there were a bit of concerns with device tree, and I mean, one of the points of using it is that it's only used at boot, because I think there were a bit of concerns with the code quality used to pass device tree. So now that would be enabled at runtime, always. So is
Okay.
this a bit, is
Yes.
this a concern somehow, or are we fine with that?
Okay,
Should we
so-
do something to the device tree code in order to enable to use it at runtime?
I'm speaking prehistoric time, but the libraries that we are using for parsing device tree, this one is awful, right? It's handling some corner cases that we don't need, and from a safety point of view, it's a mess. At least what I have done in the past is saying that I don't care, because from that, we would need to modify a bit Xen, but basically you parse the device tree to generate an internal structure from it, using enums and etc. and whatever you name it. And then that's what you take as source of truth. So it's just a converter, and you don't care anymore. But I think somehow device tree is nice for one main reason, is that you don't have a dependency to any version. That's a binary blob. And if you change the internal structure, or you have the possibility internally, if it's not in the device tree, you don't care. If you have in the device tree something that you don't know, you can also don't care, right? You have something, okay, it's there. I don't know what it is, but I will continue my life.
Yeah, I mean, my concern is that if you will be able to crash the hypervisor by passing a corrupt device tree or something like that.
One more comment. We're about 10 minutes.
Okay, I'll make one simpler answer is keep in mind that it will be a privileged hypercall. I mean, in our model will be the control domain, the only one, because it will be the equivalent of the create domain hypercall or the destroy domain hypercall. So you don't expect the hypervisor to protect itself against a DOM0 equivalent that has that level of power, because that VM can reboot the system, right?
Secure boot.